Hello everyone, welcome back to my channel Gems of Knowledge. So I am here with another video on the topic exercise questions for the Is Matter Around Us Pure chapter. Okay, so before we start the video, make sure to subscribe to my channel and also click on the bell button to get the notification as soon as I post my new videos. So here you can see the first question is onto the screen. So here the first question is, which separation techniques will you apply for the separation of the following? So here few questions have been given and you have to identify which techniques you are going to apply to separate these things. Okay, so the first thing here is sodium chloride from its solution in water. So these yellow color ones are nothing but your questions, and the green color one which is written below them is nothing but the answer to that, the technique which is used in separating those one. Okay, so here first one is sodium chloride from its solution in water. So how can you separate the sodium chloride from its solution in water? So sodium chloride is nothing but the salt. So when you are mixing salt into the water, so which is the technique which is used to separate this is nothing but evaporation technique. Okay, then coming to the second one, you can see ammonium chloride from a mixture containing sodium chloride and ammonium chloride. So here you have to separate ammonium chloride from the two components mixture, that is sodium chloride as well as ammonium chloride. So the technique used here is nothing but sublimation. By using sublimation technique, you can separate ammonium chloride out of sodium chloride and ammonium chloride. Then the third one is small pieces of metal in the engine oil of a car. So how can you remove this? So if the piece of metal is mixed into the engine oil, so what is the process to remove this? So the technique which is used to separate this is nothing but filtration. If you filter the engine oil, obviously the metal pieces will be left behind and the oil will be poured into the bottle or whatever the container you are using. Okay, then the last one here is different pigments from an extract of a flower petal. So if you are taking out the extract of that flower petal, so you can see different types of pigments will be coming out. So this can be separated by a single technique which is known as chromatography. Okay, so you can see the next one here, the butter from curd. How can you remove the butter from curd? By the process of centrifugation. So I told you the machine, into the machine when the butter is kept, so you can remove the, curd is kept, you can take out the butter from that curd by using this technique. Then oil from water. So oil from water is also removed by the technique called separating funnel. Similarly, one more here, tea leaves from tea. So obviously we do filtration process when we are going to drain the tea from the tea leaves. Okay, then iron pin from sand. So iron pins can be removed by by the process of magnetic separation. So if you take the magnet piece and go into if you go nearer to those iron pieces or iron pins which are mixed into the sand, obviously what happens is the iron pins will get attached to that magnet and it will be removed out from the sand. Next is wheat grain from the husk. This is a physical process known as winnowing. Okay, then comes fine mud particles suspended in water. So this fine mud particles which are suspended into the water can be removed by the process of filtration. So moving to the second question, you can see the second question here. Write the steps you would use for making a tea. So here we have to write the steps how we are going to prepare a tea. So here the keywords have been given. Use the words solution, solvent, solute, dissolved, soluble, insoluble, filtrate and residue. By using this word, we have to explain in the steps how we are going to prepare a tea. So the first step is dissolve a solute. Okay, that is so the solute which we are taking here is nothing but the sugar as well as tea leaves, okay, into the solvent. Obviously I told you the bulk one which we are taking in the huge quantity will be always solvent, and the smallest particles which we are taking in the small quantity is nothing but known as solute. So here the solute are sugar as well as tea leaves, whereas the solvent will be water. Okay, this is the first step. Then coming to the second step, sugar will be soluble whereas tea leaves are insoluble. We all know this. When we are going to prepare a tea, when we add sugar into it, the sugar will get soluble into it, whereas the tea leaves will be floating onto the above surface of the water. Okay, then the third step will be boil this mixture and filter it. So what we have to do here is we have to boil this mixture and we have to filter it. Then the last step here is the tea solution can be collected in a container and the tea leaves will be left as the residue. Obviously what we will do here is after filtration, what happens is tea solution we will get and the tea leaves which are floating onto the surface of the water will be separated. So moving to the third question, you can see the third question onto the screen. Pragya tested the solubility of 3 different substances at different temperatures and collected the data as given below. Okay, so here a table will be given in which there is data where the Pragya, what she has done is she has tested the solubility of 3 different substances. Okay, there are 3 to 4 different substances and she has collected the data by testing them at different temperatures. Okay, so in the bracket what is given? Results are given in the following table as grams of substances dissolved in 100 gram of water to form a saturated solution. So these are nothing but they are dissolved into the 100 gram of water to make the saturated solution at different temperatures. Okay. So here you can see the table here. Okay, the substances dissolved, you can see the below purple color box contains 4 types of substances. One is potassium nitrate, second one is sodium chloride, third one is potassium chloride and the fourth one is ammonium chloride. So on the right side they have shown temperatures in Kelvin. So there is 283 degree. Okay, so 283 degree, 293 degree, 313 degree, 333 and 353. So below them are nothing but the solubility of that particular substances. So what is the first question here? What mass of potassium nitrate would be needed to produce a saturated solution of potassium nitrate in 50 grams of water at 313 Kelvin? So at 313 Kelvin you can see what is the mass of the potassium nitrate. You can see here potassium nitrate is having the mass of 62. It is having the solubility of 62. So what they have told here is you can see here 50 grams of water they have told us. Okay, so in 50 grams of water what will be the solubility of that particular product? So in the question what we have learned is we have dissolved it into the 100 grams of water. Okay, so you can see the answer here at 313 Kelvin for 100 gram. What is the solubility given here? It is 62. Now we are going to calculate it for 50 grams. So what will be the solubility? What we have to do here is we have to divide that 62 by 2. Okay, so 50 grams means it is exactly half of the 100, right? So what we have to do is 62 grams also we have to exactly divide it by 100. So what we are going to get there? 62 when it is divided by 2 we are going to get is 31. So in that the third question, one more question is given, that is B1. So the question here is Pragya makes a saturated solution of potassium chloride in water at 353 Kelvin. Okay, so what she is making? She is making a saturated solution of potassium chloride in water and leaves the solution to cool at room temperature. So what would she observe as the solution cools? So we have to explain what she is observing when the solution is cooled at the room temperature. So here the solution is, as the solution cools, she will find some solute at the bottom. What happens? As the solution will cool down, the solution, the powdered form of that solution will be settled at the bottom. So on increasing the temperature to a certain extent, what happens here is it will result in more solute getting dissolved into the solvent. So whatever the powdered form or the sticky form it is situated at the bottom of the your vessel, no, it will be again, it will to some extent it will get dissolved into the solvent, but as soon as it get cools, what happens, it will go into the bottom of this flask or the container, and it will settle at the bottom. So hence when cooled, solute remains at the bottom. Yes, so the third question here is, find the solubility of each salt at 293 Kelvin. Which salt has the highest solubility at this temperature? Okay, so what is the question here? We have to find out the solubility of each salt. Here 4 salts have been given, and we have to find the solubility of each of the salt at 293 Kelvin. Okay, and we have to identify which salt has the highest solubility at this temperature. So you all can see the table here. Okay, here you can see the substance dissolve has been given. These are nothing but the 4 different types of salts given here, and these are nothing but the temperatures are given into the Kelvin. This is 283 Kelvin temperature. At this temperature, what is the solubility of this potassium nitrate, sodium chloride, potassium chloride, as well as the ammonium chloride? So at 293 Kelvin, these are the solubilities, and at 313 Kelvin, these are the solubilities. Similarly, at 333 and 353, these are the solubilities. So according to the third question, we have to find out at 293 Kelvin, at this temperatures, okay, what are the solubilities we have to find out. Okay, so the first one among these is nothing but potassium nitrate. So what we need to find out, what is the formula to write the solubility? The formula to find the solubility is mass of the solute divided by mass of solution, and it is multiplied by 100. So this is nothing but the formula to find the solubility. So here we need mass of the solute as well as mass of the solution. So what is the mass of the solute? It is nothing but 32 grams. Okay, it is already given into the tabular column. Okay, next, mass of the solution. How can we find the mass of the solution? What we have to do is, we have to dissolve this mass, that is 32 grams, into 100 grams of water. It has been already told in the question that into the bracket that the gram of the substances were dissolved in 100 grams of water to make the saturated solution. It was previously told, okay, into the question. So what we have to use here? We have to use 100 here. So what will be the mass of the solution? 32 plus 100, it will be nothing but 132 grams. So let us substitute into this formula. What is mass of the solute? It is nothing but 32 grams divided by mass of the solution is 132 grams, and it is multiplied by 100. So after cancellation and after dividing and multiplying, we will get the answer as 24.24%. Okay. Similarly for sodium chloride, mass of the solute is nothing but 36 grams. Mass of the solute is 36. We have to dissolve into 100 grams. So it will be 36 plus 100. It is nothing but 136 grams. So same formula we have to apply. So 36 divided by 136 multiplied by 100. We are getting the answer as 26.47%. Then the third salt is taken as potassium chloride. Here the mass of the solute according to the tabular column is given as 35 grams. And when we take the solution of that, mass of the solution, we will get 35 plus 100. It is nothing but 135 grams. Let us substitute into the formula. We will get 35 divided by 135. It is multiplied by 100. The answer what we get is 25.92%. Okay, the last one here is ammonium chloride. So what is the mass of the solute here? It is nothing but 37 grams, and mass of the solution will be 37 plus 100. It is nothing but 137 grams. So solubility, when we apply the formula, we will get 37 by 137, which is multiplied by 100. We get the answer as 27%. So here the next question is D1. What is the effect of change of temperature on the solubility of the salt? So we have to identify what is the effect if the temperature is changed, then what is the effect on the solubility of the salt. Okay. So what happens here is, according to the answer here, the increasing temperature to a certain extent also increases the solubility of the salt. So as we increase the temperature of that particular solution, what happens is the whatever the salt is present into the particular solution, that salt will be dissolved more. To some extent it will again dissolve. Okay. So the fourth question is, explain the following by giving examples. So here few more questions have been asked into this. Okay. So the first one, A1, is saturated solution. So we have to explain what is saturated solution along with the examples. Okay. So what is saturated solution? The solution that dissolves as much as solid as it is capable of dissolving at any temperature is called as saturated solution. So what is saturated solution? It is a type of solution which can dissolve the solid, okay, solid or solute, whatever it is, at a particular temperature. So when we are giving the temperature to that particular solution, so what is the extent it can dissolve the solid, that particular thing is called as saturated solution. So example you can see here, 2 gram of potassium nitrate completely dissolved in 100 gram of water. So when you are giving temperature to this liquid potassium nitrate, it will completely dissolve into the 100 gram of water. Next, B1 is pure substance. So we have to explain what is pure substance. A pure substance consists of a single type of particle. So pure substance are those substance which contains only one type of particle. So example you can see oxygen, hydrogen, etc. So all these types of gases are nothing but the pure substances. Next comes colloid. So what is colloid? Colloid is a solution in which a material is evenly suspended in a liquid. So colloid is such a thing which is in which the material will be suspended into the liquid. Okay, it means there is non-uniform distribution into the liquid. So example you can say milk. Milk is an example for the colloid. Next one is suspension. A suspension is a heterogeneous mixture. Okay, it is a heterogeneous mixture in which the solute particles does not dissolve but remain suspended throughout the bulk of the medium. So here also the condition is the solute particles will not completely dissolve here, but they will be suspended. They will be into the solution, into the bulk, okay, in the bulk throughout the medium. So example you can see dust, when it is added to water, it will not completely dissolve. Okay, it will be surrounding the water, it will be into the water, it will be roaming into the water, moving into the water. So the fifth question here is, classify each of the following as homogeneous and heterogeneous mixture. So in the bracket few questions have been given, few words have been given, and we have to identify them as homogeneous as well as heterogeneous mixture. So the first one here is soda water, then wood, air, soil, vinegar and filtered tea. So according to homogeneous mixture, what is homogeneous mixture? Homogeneous mixtures are nothing but the mixtures where there is uniform composition of the substance is uniform. Okay, so according to the question here, the homogeneous mixtures are soda water, wood, air, vinegar and filtered tea. And the one which comes under the heterogeneous mixture is nothing but the soil, because here there is non-uniform composition into the heterogeneous mixture. Next, moving to the sixth question. Sixth question is, how would you confirm that a colorless liquid given to you is a pure water? So the question is, how we can confirm that the colorless liquid which is given to us will be a pure water. So how we can do that is, if the colorless liquid does not undergo Tyndall effect, then the water is pure. If it undergoes the Tyndall effect, we can say that the water is not pure. If the solution does not undergo the Tyndall effect, then we can surely say that the water is pure. So the next question is, which of the following materials fall in the category of a pure substance? So here few questions have been given: ice, milk, iron, hydrochloric acid, calcium oxide, mercury, brick, wood and air. So we have to identify among this which is a pure substance. So according to pure substance means it consists of only one type of material, okay, or we can say it may be either a element or a compound. Okay, so here you can see ice, iron, hydrochloric acid, that is nothing but HCl, okay, and calcium oxide, CaO, and mercury. Mercury is a pure metal. Okay, so these are nothing but the pure substances. Ice is a pure substance because it contains hydrogen as well as oxygen. Okay, iron, Fe, then hydrochloric acid, HCl, as I told you, calcium oxide and mercury, these are nothing but the pure substances, and the remaining one, they are nothing but the mixtures. So the next question you can see here, that is 8th one, identify the solutions among the following mixtures. So into the bracket they have given the options: soil, seawater, air, coal and soda water. Okay, so let us see the answer here. So solution among the following are the water, air and soda water. So among this, these three, water, air and soda water, are nothing but the solutions. Okay. So next question is 9th one, which of the following will show Tyndall effect? So here also few options have been given and we have to identify which among the following will shows the Tyndall effect. Okay, so here salt solution, milk, copper sulfate solution and starch solution. There are four options here: salt solution, milk, copper sulfate solution and starch solution. So the one which shows the Tyndall effect is milk and the starch solution. Okay, these are the two things which shows the Tyndall effect. Next, 10th one question, classify the following into elements, compounds and mixtures. So again the options have been given and we have to classify them into elements, compounds as well as mixtures. So options are sodium, soil, sugar solution, silver, calcium carbonate, tin, silicon, coal, air, soap, methane, carbon dioxide and blood. So we have to identify these things into elements, compounds as well as mixtures. So among this, the elements are sodium, silver, tin and silicon because they are made up of single type of substance. So they are called as elements. Okay, and they cannot be broken down into again simple substances. Okay, then comes compounds. Compounds are nothing but they are having the fixed composition and they can be broken down into its components. Okay, so here the compounds are calcium carbonate, methane and carbon dioxide. They can be again divided, so they are called as compounds. Okay, then coming to mixtures, soil, sugar solution, coal, air, soap and blood, these all are nothing but the mixtures. They contain a number of things into them, so they are called as mixtures. Okay, so the last question here is, which of the following are chemical changes? Okay, so we have to identify which among the following are nothing but the chemical changes. So here the options are given: growth of a plant, rusting of iron, mixing of iron fillings and sand, cooking of food, digestion of food, freezing of water or burning of a candle. Okay, so among this, which are the chemical changes? So except mixing of iron filling and sand and freezing of water, all the above mentioned are a chemical change. Okay, so here you can see growth of a plant. Okay, if the growth of a plant is increased, if the plant has been grown, then we cannot reverse this process. So chemical change are such a process which are irreversible. We cannot reverse them, and the product which we get is something new substance. Okay, so the two mentioned here, that is mixing of iron filling and sand and freezing of water, are nothing but the physical changes. Okay, so that's all for this video. If you are having any doubts regarding this, you can comment me down below and I'll be back soon with another video. So till then, stay safe and stay connected. Thank you.